I'm going to go through 4.8 first, and let's see some examples for 4.9 together. So 4.8 is all about find out the Green's function. Okay. So the Green's function is actually like a recall from 4.7 from the variation parameter, like we use u1, y1, and u2, y2, so on. So yp. So here is the general step to find the Green's function. First, the equation looks like this, and it will give you two initial conditions, that is yx0 equals y0 and y prime x0 equals y1. And so and the final solution is y equals yh plus yp. So here yh is the homogeneous equation, it's solution for the homogeneous equation, and yp is the particular solution. So to find out the Green's function, first we need to find out what is yh. So yh is equals y1 plus y2, and these are the two solutions from the homogeneous equation. Once you find out the y1 and the y2, you can figure out what is w here, right? So w equals y1, y2, and y1 prime, y2 prime, and you multiply y1, y2 prime minus y2 times y1 prime. So that is omega. And once you find out omega, and you need to figure out what is y1 prime and the y2 prime in order to find y1 and y2. So y1 prime here is so I think it's negative y2x plus fx. So fx is here over w, and y2 prime is y1x times fx over w. So in this case y1 is just the integral. So here we have the initial conditions here, and we put x0 at here. So we integral start from x0 to x, and we change the x here into t. So y1 is integral from x0 to x, y2 t times ft over y2 is 0x y1 t ft wt. So that is y1 and y2. So yp is y1 is u1 y1 plus u2 y2, right? And in this case, we put u1 and u1 u2 and y1 y2 here. So yp is so that is y1x, and u1 is integral from x0 to x, and negative y2 t over plus this part is y2x times integral from x0 to x, y1 t f t over omega t dt. So if we sum them up, it will become the integral from x0 to x. And here we have ft, and here we have ft, so we can throw out the ft. And the other part will become negative. So that here is y1x times y2 t. And here is plus y2x times y1 t, and over omega t. So that is the final answer for yp. And we call this whole part the green function. That makes sense? Yes, true. Actually, you need to remember this equation, so I just explain step by step to make you better understand. Yeah, that's why where the green function comes from. So the green function is negative y1 x y2 t plus y2 x y1 t over negative w2 negative. So that is green function. So for 4.8, we are going to use this equation to find out the green function. Let's take some examples. And for this one, we are going to find out the green function. So the first step, we are going to find two solutions from the homogeneous equation. So the homogeneous equation is that the red part is zero, so that will become omega squared minus 16 equals to 0. And 1 equals to 4, and 2 equals to negative 4. So y1 here is e to the 4x, and y2 is e to the negative 4x. So once we find out the two solutions, we can find out the derivative. Right here is e to the 4x, e to the negative 4x, and with the derivative of this, so here is 4 e to the 4x. Here is negative 4 e to the 4x. So w equals negative 4 minus 4, because 4x minus 4x is 0, so e to the 0 is 1. So here we got negative 8. And okay, so this is so under step 3, we can find u1 and u2. So we call that u1 prime equals, we didn't do that actually. So we call the green function. So gx equals negative y1 x y2 t plus y2 x y1 t over omega t. So we have our y1, y2, and we have the omega wt. So we can put all the values into this equation, and we get. So here is still y1x is equal to e to the 4x here, and the y2t is e to the negative 4t. I changed the f to t because it's y2t. And the plus y2x is e to the negative 4x times y1t is e to the 4t here. And the wt is negative 8. So this is the green function. And then we can make it more specific. So let's say here is, so here is a negative, so I want to get rid of the negative for the numerator, so that is e to the 4. Here I combine this part, and this part is will become 4x minus t. And here I want to get rid of the negative sign here, and the formula becomes plus, and this becomes minus, so it's minus e to the negative 4x minus t over 8. So recall that sin x equals to e to the x minus e to the net x over 2, and we can see that we can transfer this equation into slash, so that is 1 over 4. Here is 2 e to the 4x minus t minus e to the negative 4x t, so it will become 1 over 4 slash so the final answer will become 4x minus t. So this is our Green function. So have any questions so far? Okay, so the biggest thing is that you really need to remember this equation and to remember it correctly. And if you just forgot the equation, you can use the process I'm doing at the very beginning of the session to get the function. So once you find out the Green's function from yt is x0 to x, and here is the we can use the Green function to find the particular solution. So that is x0 to x, and here is 1 over 4 slash 4x minus t, and here is ft. Ft here is t times e to the negative 2t a2. So this is our yt, and the final solution is yh plus y2. So yh is the true solution from the homogeneous equation, so that is C1 is e to the 4x plus C2 e to the negative 4x, and you put this here, so that is the final solution. So for this one is the first step, we need to find the solution from the homogeneous equation. So that is n2 plus 9 equals 0. Here we find out that the solution for m is a complex number. So m equals positive matrix I. And our true solution is y1 equals cosine. Oh, sorry. So y1 is cosine 3x and y2 is sine 3x. And what is that? Omega equals the cosine 3x negative 3 to the sine 3x. Here is sine 3x. This is equal to 2 cosine squared plus 3 sine 3x squared, which equals to 3. And the Green's function is so y1x is cosine 3x times sine 3t plus sine 3x times cosine 3t over 3. So sine x plus y equals sine x cosine sine x cosine y plus cosine x sine y. So here we can see that the denominator is sine 3x minus 3t over 3. So that is the Green's function. And our yt is the integral of the Green's function multiplied by the fx. And there is 1 over 3. And here is 3x minus t times t plus sine t. And for the final solution, we need to add this and the two solutions from the convention together.
Yeah. So it's really good that we just have that and then just be like applying.
Well, you can yeah, you can find out the integral of this, but I don't know for this one. I think, yeah, so you can find out the integral of this. And I will like go through a problem that will evaluate this. Okay, so this one so just as the first two examples, we need to find the two solutions for the conventional one. we get, so here m1 equals m2 equals 5. Y1 is e to the 5x and y2 equals x e to the 5x. And the green function is minus y1 x y2 t plus y2 x y1 t over omega t. So it's negative e to the 5x. So y2t is t e to the 5t plus x e to the 5x times y1t is e to the 5t and divided by e to the 10t. And it will become, so 10t and so 5t cancelled with 5t in the denominator, and here e to the 5t cancelled with e to the 5t as the denominator, so it will become negative e to the 5x times t. This part is cancelled, so this becomes 5t, and plus x e to the 5x or e to the 5t here, and so it will become this x minus t, so it's x minus t times e to the 5x. So that's the brain function, and wait, no. So here is 5x minus t, because x is in the numerator and the t is in the denominator, so that is our green function. So once we find out the green function, we can find the yp. Wait, so here is the x0 is 0, so we integral from 0 to x, and we use the green, we multiply. So here we function and multiply by the ft, and it will become net 0. Green function is x minus t e to the 5x minus t, and our ft here is e to the 5t. So here is e to the 5 negative 5t, and here is positive 5t, so this t cancel each other. It will become 0 to x minus t e to the 5x dt. So at here we can take evaluate this integral, right? Because it will become 0 to x times e to the 5x dt minus 0 to x t times e taking integral of t. So we can consider x to a constant. So we don't need to we don't need to pay attention to x here. So at this part it will just become x e to the psi x. So the 0 x 1 dt. So this part is just the t, and the minus here is 0 x. We take out e to the 5x, and we take integral of t dt. And this part will become 1/2 t squared. So yt equals x times e to the 5x times t minus e to the 5x. One here is from 0 to x, and here is 1/2 t squared from 0 to x. So it will become here 0 to x is x minus 0, right? So it's just x here, and it's just x squared here. So the final answer for yt is, so here is the x squared. It's 1/2 x squared times e to the 5x. So that is our yt. And for the final solution, we combine yt with the cosine combine yt to the solution from the final one.
Where does that do the cos t
Here.
come from?
So this one is from here.
You already did that.
So this is f(x), right? yt is the integral of Gaussian function times ft.
Yeah.
dt.
You already did that. Because your w of t is e to the 10t, right?
Yeah.
And then you multiply it by f of t, which would be e to the 5t. So you get x minus t times e to the 5 x minus t.
So you mean for the w? So the w is e to the 10x, right?
Yeah.
And so the Gaussian function is so for the Gaussian function is something here and over wt.
Yes.
So I'm putting here to here.
Yes.
And once I find out the Gaussian function, I want to find yt. Yt is the integral from x0 to x, Gaussian function times ft. So that's why I multiply e to the 5t here.
No, you did.
Okay. So, any questions or comments? Okay, so let's go to point 5. We're trying to solving the two ODE from the system. So in this case, there will try to find out xt and yt while using these two equations. So it's just like a polynomial, and you treat them as a polynomial, and then you try to eliminate one, either x or y first. So that's okay. Sorry, but the first step is you translate this, multiply this into d. So d is represents the derivative of x and the derivative of y. So in this case, so the first equation becomes dx equals negative dx plus y equals t, and the second equation becomes dy minus x equals negative t, right? And I want to eliminate x first. So in order to eliminate x, so the parameter from the first equation and second equation should be the same, so that I can multiply, or I can add them together, or like use first equation minus the second equation to get rid of x. So in order to do that, I need to make the parameter in front of x same. So here I'm not, here I didn't do anything to the first equation, but for the second one, I multiply c for the whole equation. So that will become b squared y minus dx equals d negative t, right? So because d is the derivative of t, so d times negative t is just to negative 1 here, right? So I have this equation 1 and the equation 2. I add them together. So because here is a positive dx and here is a negative dx, so when I add them together, those dx will cancel each other. So it will become what? D squared y times y equals t minus 1. So right now I only have y and t in this equation, so we can try to figure out yt. So we are using m squared plus 1 equals 0 to find out the two solutions from the homogeneous equation, and m just equals to positive negative I. So yc equals c1 cosine x plus c2 sine x. And for the particular solution, we can let yp equals at plus b, right? And yp prime just equal to a, and yp double prime is 0. And we put these three equations back to the original equation, it will become, here is 0 for the double prime of yp, and plus at plus b equals t minus 1. So a equals 1 and b equals negative 1. So yp is equal to t minus 1, and the final solution is yc plus yp. yc is c1 cosine x plus c2 sine x. Oh, sorry, t. c1 cosine t plus c2 sine t, and plus the particular solution here, that is t minus 1. So that is the solution for yt. Any questions so far? Okay. Okay, so once we find out yt, we can use either this equation or this equation to find out xt. So here I'm using this one. dx dt equals negative y plus t. So dx is equal to negative y plus t. And we already figured out with yt here, so we can simply replace y with yt. That is c1 cosine t plus c2 sine t plus t minus 1. And here also, don't forget the plus t here. So this part is 1. So it is, so this part is a derivative of x, so we need to figure out xt, so we need to take an integral on both sides, and we get xt equals, here is so the integral of cosine t is c1 negative c1 sine t plus it's positive. So it's c1 sine t minus c2 cosine t, and the integral of this part is so here is a minus y. This is y, so I need to add the negative sign here. So here is negative and positive, and here is negativity, and I'm sorry, so here is negative c1 cosine t minus c2 sine t, and minus t plus 1. So that is negative y, and with plus t here. So these two will cancel each other. So we have no t here. And the integral of 1 is just the t. So let's put the rectangle method to solve for the solution from this. So do you have any questions related to the plus y equals 0 and 3y minus 4x plus y equals 0. So when we combine all the x and y here, it will become 3 plus 5x plus y equals 0 and 3 plus 1 y minus 4x equals to 0. So by observing these two equations, I think probably eliminate y will be simple because here I have 4x here. If I want to eliminate x, I need to multiply. I need to use the first equation multiply 4 and the second equation multiply d plus 5. So, but if we eliminate y, we only need to use the first equation to multiply by d plus 1 to get the parameter in front of y to be equal. So I'm used to eliminate y. So the first equation should multiply by d plus 1 and it will become d plus 5 plus 1 x plus d plus 1 y equal to 0. And we say this is 3. So we use equation 3 minus equation 2. So these two parts will cancel each other and we can get d plus 5 d plus 1x. So it's minus, so it will become plus equals 0. So at this point, we get rid of all the y's and we have the differential equation only for x and t. And so here is d squared plus 6d plus 5x plus 4x equal to 0. So this is d squared x plus 6d plus here is 9x, sorry, here is x here, equal to 0, and 4 plus 6 and plus 9 equal to 0, and I get and plus 3 squared equal to 0. So M1 equals M2 equals to negative 3. And our xt is C1 e to the negative 3t plus C2t e to the negative 3t. And once we figure out xt, we can use the equations to figure out yt. So from the equation here, you can use either equation to find out yt. So let's do it using the same as this one. So our xt is this equation, and we take derivative of that, it will become negative 3 c1 e to the negative 3t. And this part is plus c2 e to the negative 3t minus 3 3t and e to the negative 3t. And it will, so this part is dx dt, and for the right part is minus 5. So x is c1 e to the negative 3t plus c2t e to the negative 3t and minus y. So y should equal to this part minus that part. So y equals to, okay, so here, y equals to negative 5x minus 3x dt, and that so here is negative 3, c1 e to the negative 3t, and here is negative 5. So when we move that part to here, it will become 2, c1 e to the negative 3t, right? And here we have c2 e to the negative 3t. Plus c2 e to the negative 3t. And here is negative 3, c2 negative 3t e to the negative 3t. And here we have negative 5 c2t e to the negative 3t. So we move that from here is plus 2 c2 and negative 3t. So it's c2 c2t, c2t e to the negative 3t equals negative y. And to find out, so y is just equal to, here is negative 2c1 plus c2 e to the, I'm combining this part, negative 3t and minus 2c2t e to the negative 3t. So that is yt. Or do you know how to solve the system? It's just like solving the polynomial. So first you need to transfer these two equations to look like this, and d represents the derivative of t. So once you eliminate either x or y to get the first equation like this, and you try to solve xt. So try to solve xt, and once you find out xt, you back to these equations and put xt back to the equation and try to find out yt. So it's just the same as like 3x plus y equals 0, 2y plus x equals 10 or something like that. It's the same, actually it's the same method to solving the ODE just as solving this. This part, the here. Okay, so right now we have these two equations, right? And eliminate y at this point. So here we say that the parameter in front of y is b plus 1, and here is 1. So if I want to get rid of y, I need to use the first equation to multiply b plus 1 first. So the first equation will become this. So here x, I multiply b plus 1, and here I multiply b plus 1, and 0 multiplies b plus 1 gets 0, right? And I use equation 3 to subtract equation 2. So this part subtract this part, they cancel each other. So I'm getting rid of all the y's. And I'm only left with this part and this part. So that is where these equations come from. Okay, so once you find out that, and so just use the method you learned from I don't know which chapter to solve for xt, and so that's step by step. And once you find out xt, you go back to that equation to find out yt. I'm using this equation to find out yt. So I need to find this for example. So this quiz is about 4.8 and 4.9. So one is to find out the Green function, and other to solve the system again. So oh, okay, sorry.
No, it's okay. That's fine. I just need you to tell you.
Oh, okay. It's over now.
Okay.
So, I'm going to